40,000 CFM dust collector. Quite a big unit, as you can see. A little bit involved with this one as far as WH&S is concerned, setup, where I put it, what its footprint is, how do I appropriate the ducting in relation to the dust that I wish to extract from the area. 40,000 CFM. It's a massive amount of air. So to appropriate the massive amount of air, you need quite a large unit to facilitate that withdrawal of air. So the volume of air that passes through this particular machine is quite extensive. To facilitate that, you've got quite a few controls here that you'll have to monitor during the course of the day. So to just start off, we've got a drive motor, which is housed within the back of this. So in relation to its operation, you have a standard operational procedure, you have an operational manual. The manual relates to all the wets that you have to check. What are the wets? Oils. You have to do your fundamental checks for battery, moist water for radiator, all of those things. And of course, there's a service tag that's always on these that you need to comply with. So say for example, the engine requires servicing at say 400 hours. You have to make sure that you are on top of that and say, okay, then this engine's coming up for service, and ensure that all of these things are done in appropriation to its longevity. So the engine itself, do I need this open while I'm running the machine? Absolutely not. Open the cage, have a look, make sure that there are no leaks. So we check for diesel leaks, filter leaks, we check our oil during the course of the day, and of course we check the water in the radiator to make sure that that's appropriate for the day. It gives you the opportunity with the lid open to check for hose leaks, anything that's chafed during the course of the day. If there is a problem, easily rectified yourself, it's all good. If you don't know how to rectify it, of course, you'll ring BlastOne and say, listen guys, I have a question for in relation to a chafed hose or whatever, and the guys here will help you out in regard to that. There's also a box at the end of the main drive engine. There's a box, an intermediate section, which is called a twin disc unit. So the twin disc is basically just a clutch. What it does is it enacts direct drive. So where the engine's running, the twin disc engages your pulley or drive belt for the fan that draws all this massive amount of air through. So the belts on it are quite substantial. As you can see, everything's guarded properly. So when you put the hood back down, you can see that the guards here have been appropriated in such a manner you can't put your hands near it. It's not something that should be just left, operated, turned on and just left. There are monitoring aspects of it during the course of the day. So, drive engine, and we've got a control box here. So prior to going through all these boxes, how to turn it on, what all these switches do, the one fundamental aspect of this particular unit, as you can see, is quite sizable. So because of its size, you need to appropriate the footprint for it. In saying that, it's imperative this machine is set up level. It's also imperative that you look at the environmental impact that this may have. What is the environmental impact? Predominantly it's just noise from this. Is it extensive? It's reasonably loud. So ensure that prior to installing this on site, it's level, it complies with the environmental requirements in relation to that particular area. And also too, facilitate the machine so that you can access waste from the machine easily. And also too, when you do remove contaminated waste from this particular machine, handle it in the appropriate manner in accordance with guidelines, and store it in an appropriate manner as well. When I say store it in an appropriate manner, one important aspect of it is always keep it dry, so that if you collect dust from this, don't allow it to get wet or permeated with moisture in any way, shape or form, because it just makes handling a lot more difficult. With all of these machines, you'll always get an operator's manual and guidelines in relation to the entire unit, so it covers everything. But if you read something in here and you think, I don't quite understand that, ring BlastOne. Guys, I've got a 40,000 CFM dust collector. I don't understand something in the manual. Can you please enlighten me in relation to that. Why do I say that? Well, basically, if you don't understand something, that means that you're going to operate a machine and I don't completely understand the requirement of that machine. So something of this size, it's imperative that all on site that intend to operate it completely understand the fundamentals in relation to its operation. So again, with all of this type of equipment, there's a WH&S requirement. I need earmuffs, I need breathing apparatus if I open any of the doors for inspection. So that's access panels I'm talking about. Also too, whilst it's running, you need hearing protection. You'll need to wear gloves when operating any of the valves on the back of the dust collector. But there are your fundamental checks that you do, as I said, which work back into your daily worksheet. That is, as I mentioned, checking fluids in the engine itself, ensuring you have enough diesel, ensuring that you have a decent air supply. Why would I need an air supply? Well, on this particular machine, you've got up on the top pulsing valves or Goyen valves. So what they do is those Goyen valves, pulse valves, shoot a shot of air through the filters that are in this unit. So a unit of this size has got a substantial amount of pleated filters in there. So the valves themselves are pulsing all day to clear the accumulated dust from the filter pleats themselves. So by pulsing, what it's doing is the fine dust that's accumulated during the period of the day, it's pulsing that away, and that dust is going to the bottom or the base of this particular unit. Also in this unit, there is what we call an auger. So the auger itself will actually drive all the accumulated waste within this housing to an end where it enables me an outlet that enables me to withdraw the accumulation and stow it in a drum, bag, whatever. But ensure that when you do set this unit up, you do have access and the right height access to be able to put a waste drum or waste bags underneath the unit. A fundamental mistake a lot of people make is to extract that dust or waste. They don't take into consideration they need to get a forklift there. So as far as the operation of this equipment is concerned, we even have a matrix, a safety matrix in relation to its operational procedure. So all of this stuff has been put together for a reason, primarily because it's designed for you to follow that information and adhere to the important notes here in relation to what can go wrong as far as this machine is concerned. If you follow all the basic setups for this, to be quite honest with you, you'll have trouble-free motoring as far as the functionality of this equipment is concerned. So all the information here is here for a reason, as a guide and the appropriate manner in which to operate their equipment. So just to run through what we've got here in front of us is we have an air inlet, moisture separator, regulator. What's it do? The air is 1 inch line, so it's a 1 inch pinch-up coupling. Safety pins, goes through to a valve. The valve, when actuated, lets the air run through the moisture separator, the regulator. The regulator should be preset before it comes to site, but what you're looking for is you want 100 psi on that. 100 psi, the line goes up and feeds the pulsing valves, Goyen valves. So the Goyen valves, as I mentioned before, keep the filters clean throughout the unit. So they assist in removing excessive dust. So this must have 100 psi over this all the time. So the inlet pressure of this must accommodate 100 psi nomination on the regulator to maintain the appropriate functionality of the pulse valves or Goyen valves through the filter pleats. Also here you can see there's an emergency stop. The emergency stop cancels this section out so that it no longer actuates, functions. And here we have the control panel for the engine itself. So the engine, the drive on this, is the most significant aspect, primarily because it makes the whole thing work. It works two things. One is it drives the big fan that draws all this air through. It has a hydraulic pump to actuate and alternate the auger to remove the consolidation of an accumulation of debris at the bottom of the cabinet itself. And so here we have a key, of course, with 3 gauges that tell us oil pressure, temperature of the engine, water, and voltage. And of course, this significant one here is revs per minute. So the reason we have to make sure that this is accessible, primarily because when we start the engine, we're going to engage the clutch, and then we're going to give it the appropriate revs to make the thing work to its optimum ability. So with all of these types of equipment, there is the key to remove to make it safe when you're not on site. Also too, when you turn the key to a certain position, you'll need to push an override switch in, turn the key, get the thing to run, hold the switch in for a few moments, the little light goes out, away we go. So that is all in here. Makes it easy for you to understand, easy to operate. Ensure that when you're finished doing your daily inspections, all these hatches are closed and the whole unit is closed up. Because it's sucking a massive amount of air through this particular unit, it's important that all the hatches are closed, everything's sealed up, so that it has the opportunity to facilitate and filter the air that it draws through from your job. So because it's 40,000 CFM, we can actually attach 2 sets of duct to this and draw from 2 different areas or alternate areas within your encapsulation. As far as encapsulation is concerned, it's important to note that you have a sealed unit as far as encapsulation is concerned. No big holes cut in the encapsulation, corners not meeting and folding around appropriately. So we're trying to enclose it as much as we can, because if you're in an environment that's got lead within the abrasive that you may be utilising, it's important to remember that the filters in this unit and the enclosure of this unit is maintained to harness and house any contamination that may be within the encapsulation of which you're working. So by doing that, say for example the filters, which are periodically replaced in this unit, if you're in a lead environment, of course those filters then are deemed a contaminant and must be dispensed with in the appropriate manner. The big box here, no need for you to access that. That's all preset for those pulsing valves. So if you find that you have 100 psi on here, open the valve, and after a short period of time, those valves aren't pulsing and you'll hear them with a sharp, clean ch. So when you hear that, you know that they're working properly. If you don't hear that after a period of time, you'll need to consult your manual to see if you've missed something in the steps, the periodic steps of procedure in relation to operation. Or alternatively, you can ring BlastOne and say, the pulse hasn't worked on this particular unit. Have I missed a step out? And the help desk will be able to help you overcome anything you may have missed. So with any unit that you send air to, there's a receiver up there, up the top. So it's just a holding tank for air for those particular valves to draw from. But with any tank, of course, ultimately there needs to be a drain valve for that tank. So as we pan through this particular unit, I'll be able to show you where you can drain that tank daily for any accumulated moisture. And it is relative to how much moisture there is in the air as to how much it draws. So in relation to draining that receiver tank on top, it is indicative to relative humidity. What's relative humidity got to do with this? Primarily if your compressor is not hooked up to an aftercool or air prep, the compressor will tend to make a lot more moisture and send it through this line. So you've got a moisture trap here, but it's not going to stop all of it. So where it says drain that daily, if it's high relative humidity, so it looks like rain for example, you'll need to drain that receiver tank up there during the course of the day. So periodically, just crack that valve on the drain for the tank to ensure that there's not excessive moisture in that receiver sent through the Goyen valves or the pulse valves. Make sure that when you put your hose, your connecting coupling here, the A-type coupling, you do put 2 pins in it and appropriate the hose out of the way. Also too, while we're in this area, it says on this particular unit, particularly on the base, it said spreader bar must be used when craning this equipment. So in a spreader bar, all it's doing is where the chains or the slings are, it spreads the load away from this particular unit, because if you lift this unit without utilising a spreader bar, you'll actually squash the top of the container where the slings or chains come up. So the apex of it is spread at a distance utilising what we call a spreader bar. So that's utilised whenever we lift this with a crane. Also too, you'll have on this, in the centre on either side, is an indication to the crane driver or the dogman where the centre of the unit is, to give them some indication in relation to lift and centralisation of that lift. So imperative aspects: spreader bar, centralisation, spreading the load, making sure that it's all appropriate prior to lifting this equipment. So it's easy to forget those type of things. I mention that because it is an easy oversight. So spreader bars, appropriate lifting lugs, and they are weight rated lugs. So we utilise the lugs themselves. We don't sling around alternate aspects or parts of this particular frame. We utilise the lifting lugs. They're there for a purpose, use them. So systematically we're going around filming this particular unit. We're actually doing a walk around, which is something you'll do prior to operating the equipment. So where we are at the moment is almost centre of the unit. We've got this drain tank daily. That is for the receiver that I was talking about for the pulse valves, Goyen valves. So this is the valve that you'll actuate to drain that valve. Remember, it's compressed air, so of course you won't put your face under there and open the valve. You'll stand back, have the appropriate PPE on, which is glasses, earplugs, and release that valve. Only need to release it slightly. You don't evacuate the entire valve because the noise would be quite significant. Now further down here we have another valve system, and here's the operational handle for that particular valve system. So this is hydraulic. So we've utilised hydraulics on this unit because hydraulics is a lot more responsive and has a lot more torque in relation to moving the auger that is centred right through the entire cabinet to remove the dust and dirt and debris. So an auger will turn and wind the accumulation of material within this cabinet. So again, with augers, anything that's hydraulically driven, of course it's dangerous, so make sure you adhere to the safety instructions and requirements in relation to its operation. So in this particular one we've got reverse, which winds the auger backwards, and we've got empty, so it's actually winding, the auger's winding the material this way. So it's going forward for empty and aft for reverse. So basically what we're looking to do is empty the thing. And the valve release is set to 55 bar, do not exceed setting, as this damage may occur. So there's no need for you to alternate the pressure setting valve on the back of this valve body or valve chest. Primarily it's factory set, so every time this machine's serviced, valves like this are checked to ensure that they are appropriated to 55 bar. Do you need to touch any of this? No. All you need to do is operate this handle for forward and reverse. So you'll find that reverse is spring loaded and returns, but your operation to empty stays in that position. It enables you to turn around and ensure that's appropriating what it's designed to do. These hoses here should not be damaged. They're hydraulic hoses, so therefore they carry a high pressure. They're also done up nice and tight, so on your periodic daily check walk around, you'll make sure that there's no hydraulic oil leaking from those particular items. They are a sealed olive fitting, high pressure. There shouldn't be any leaks. In this particular cabinet door here, which is something that should be closed at all times, and it says here, caution, always use safety equipment when servicing dust collector. So basically the fines in here are very fine. So You will have a respirator on, you will be kitted out, you'll make sure that you have, and it pays to wear something like a spray hood if you're going to do anything inside this cabinet, and remember it is a confined space. So to give you an indication what's in here, this is the filter that this particular unit draws through and pulses during the course of the day. So there's a significant number of filters in here. So that's why it's important you give the filters an opportunity to work appropriately. So say for example, I didn't shut this door properly and I thought, oh, she'll be right, I'll leave her there like that, no problems. In actual fact, what's going to happen, it's going to draw through any opening that you leave, and it gives it the opportunity to suck air in, not from where you want it, but it's sucking atmosphere in instead of the appropriation of the ducting that you're putting in your encapsulation. So things like doors, you'll see that they've got rubbers around them. Why would they have that? Ultimately, we're looking for an adequate seal. So in essence, what happens is when they seal up, and we've got the rubber seal and the door kissing each other, it appropriates a vacuum, and the vacuum is throughout the entire cabinet. So if you do have to undo any of these sections, just make sure that you put the nut and washer in an appropriate place so that you can restore them as you found them prior to dismantling them. Is there any need for me to look in here? To be quite honest with you, no, there's not. The machine itself pulses these filters, keeps them clean. The only time I need to look in here is if I have an auger jam. What's an auger jam? If you do not, periodically during the course of the day or the operation of this machine, operate that auger to remove some of the debris that you've accumulated within the machine, the auger does not have the capacity to empty the amount of dust that might accumulate over 3 or 4 days to this height, because all it does, because it's fine dust, it consolidates. And in that consolidation, there's a torque value, and the torque value is appropriated on that particular auger. So the auger has a section of fins that turn around and wind the rubbish backwards. So that's why I was saying when it's going forward, it's pulling it out this way. So if you let that fines accumulate to such a degree that it's quite weighted, the auger is trying to do a job that's almost impossible, winding something that's solid out of the unit. And that's why relative humidity comes to play. Say for example, it was raining for the week, relative humidity is high, the encapsulation is not environmentally controlled with dehumidification, you'll find that dusts will absorb moisture. Well, the same thing happens in here. So that if, for example, it's rained for the week, this will tend to sweat. So that's why we have a periodic dumping of the fines to eliminate that consolidation of grit and debris. It becomes a systematic, fundamental requirement during the course of the day. And once you start doing it systematically, you'll find that everybody's on the same page and understands that this has to be evacuated periodically during the course of the day. So if you follow that procedure, you'll find that you'll never have to open this door to say, oh, look at that, the auger's jammed. So ultimately what you're doing is you're eliminating the need to access this particular unit, because fundamentally I've followed procedure and I've done that procedure systematically. So in this end of the unit we've got a sight glass, the ports, the ventilation ports, and we've got the end drive of the auger. So what this does, it enables me to see within this chamber. So why would I want to look in here? Well, because it's the primary side of the chamber and we've got in the back of that a plenum, so the plenum appropriates the air around it. What it's doing is it's sucking it with immense force into this area. So all the stuff that's being drawn out of the atmosphere in your encapsulation ends up going through here first. So we have a primary side, secondary side. The primary side is where all the big stuff goes. So say for example, within that stream of air, there was sticks, rocks even, branches, all this sort of stuff. The big stuff will end up in this side. So all this is doing is do the primary clean. Inside here you've got some mesh on the bottom of it to stop the big items dropping down into the auger and save you getting inside and pulling it all out. So the sight glass gives me the opportunity to have a look periodically during the course of the day to see what the build-up is of those debris. So obviously, if the debris becomes quite surmountable, what I'll do is I'll stop the machine, take the ducting off and remove those big debris to stop restrictions, because ultimately you get enough in there, it will become a restriction. And also too, they'll go to the back of the plenum and become difficult or wedged, difficult to remove. So again, you see what I mean? It's not something you just turn it on and walk away and leave it. You have to look at the environment that you're in and say, okay, then we'll look, there is a lot of stuff floating around here, paper and so forth. So if it does end up in this environment, it gives you the opportunity to view this primary chamber to ensure that you can remove the debris. So this is where your ducting goes on. This is where you attach it around here, and you can put a band around here or even use a simple thing like duct tape to hold your ducting on there, because you remember it's being sucked on there. So it's not as if there's something that's going to give it a reverse type of inertia and blow it off. It's going to be sucked on there. So believe me, it wants to stay on there at 40,000 CFM. So you've got 4 here. So say for example I needed all 4, of course I would take the blanks off and run all 4. Most jobs require 2. It depends on the environment and the cubic meters that you're trying to extract the dust from. And it even says here, blank off extra inlet ports when not required. So I might need 3, 2, probably even 1, depends on what I'm doing. So appropriate this to the requirement on the other end. Now, as I mentioned here, this round drum is the end of the pilot drive of your auger. So this is a bearing, the auger suspended inside this housing, and there's always notations throughout the machine to alert you as to what's required. Never activate discharge until ensuring waste bag is sealed to the outlet. Waste bag is sealed to the outlet. So what's that mean? Well, we have another butterfly valve here, and the butterfly valve itself closes that valve here, because you've got to remember you were trying to suck air through here. So we don't want to create a vortex inside there by leaving this open. So this is closed during operation. So when would I open this? When this is set up properly, and as I mentioned earlier, you'll appropriate a waste bag or drum underneath this. It's important to remember too that that waste bag or drum is sealed around the top, so when you open this particular valve, that all the debris is dispensed within the drum or the container that you appropriate underneath this particular valve. The importance comes with the type of environment that you're cleaning and the dust is being removed. So for example, lead. If it was a lead environment, you would be pedantic about setting up the drum, appropriating a seal to ensure that it can't escape and you don't overfill the drum. And it even says here, warning, do not overfill waste drum. So there's all these little reminders around this unit with labelling in relation to its operation. The important thing to remember too, that if I appropriate a drum underneath this, that I do seal it up, but I still need to be able to know when it's full. So just remember that you need to periodically check to see how it's going in relation to its dispensation. You can operate this valve with the machine running. Personally, I'd be more inclined to stop the functionality of the dust extraction and then dump this. Why would I do that? If I disengage at the other end, it's a lot quieter this end and I can hear what's going on. So then I can understand what's going on in relation to this here. Also too, with the machine running, it tends to have a diverse effect in relation to how it dispensates that. Because gravity still plays a part in this. You can see the shape of this, so all the debris tends to fall to the centre. So while the auger is driving this back towards me, that means that the rubbish that's fallen in the centre is being driven back. So it's mechanically moved back towards the end of this dispensation valve. So with the spring lever to hold the valve closed, I can release the spring and open the valve. Now, without the machine drawing over the top and gravity playing a part in this, by opening this valve, it all comes and falls back this way, whereas if you have the machine running, it tends to create a little bit of a vortex the minute I open that. And that only happens when there's not a lot of material in there. When there's the appropriate amount of material in there to start removing it, you'll find that it seals itself off, so that if you have this running, it'll run out for a period of time, and then it'll start to, you'll see this little vortex arrangement starting to eventuate here, and you know that you're getting towards the end of it. So it's really an individual thing. Personally, I prefer to turn that off so that I can hear and see what's going on here. So make sure you keep this area clean, so give it a wipe down periodically. And of course, remember that this is the end of the shaft, and this is where the bearing is for this particular auger. They always have lubrication points. In this case, it's a grease nipple on the top. One mistake a lot of people make is they say, oh yeah, there's a grease nipple, we'll whack a bit of grease in that, she'll be fine. Always wipe the top of the grease nipple and make sure that there's no accumulation of old grease on the top prior to initiating the nipple over the top, because the grease lubrication nipple is going to be depressed. That little ball bearing in the top is depressed. So any rubbish or debris that's left on the top and you start greasing that, whatever that debris was, you've just impregnated those roller bearings with that debris or contamination. So make sure they're clean and wiped clean. Normally what I do on this end is I'll wipe that once I've greased it and put a little bit of tape on there, a little bit of duct tape. It just makes it easier, so next time I come along I just whip the tape off, whack the grease nipple on there, away I go, squirt a couple of pumps. Do I stand here and pump for half an hour and think, yeah, it must be greased, it's got to be greased now? Ultimately, it only needs 2 or 3 pumps a day. So at the end of the day, when I go around and do my walk around, or even when I start up of the morning, wipe the nipple, couple of pumps, and I mean pump, pump, that's it. If you see it oozing out the back of the seal here, you know that it doesn't need any more grease. So common sense prevails. Keep it clean, keep your hands away from, don't go putting your hand up inside there when you're operating that auger. How can I put my hand up there? Well, you can't really, because ultimately, remember what I said? You're going to seal the drum and make sure that the dust can't plume out while I'm trying to empty the unit. But that's not to say that somebody won't put their hand up in there. With the butterfly open, there's a small gap there, you can put your hand in there. Would you want to? Absolutely not. It'll drag your hand clean off. So there's a safety, an imperative safety aspect of this. When that auger's operating, don't take the cover plate off and put your hand in there. Don't put your hand up underneath. You will lose it. So here we are on the alternate side of this particular unit. And look, we've got another one. So there's 2 banks of Goyen valves here. Because there's so many filters, we need a lot of valves to facilitate the pulse within those filters. So again, you've got another drain valve. Also, safety glasses, earplugs, drain that periodically. So it says drain tank daily. If you're doing a walk around, it doesn't hurt just to crack that valve open marginally to enable any excessive moisture to be dispensed from the receiver tank up top. Further back here, we've got what we call a hydraulic oil tank. There's no need to access that, no need to take the lid off it, no need to undo it. Ultimately, it's got a sight glass in it. A sight glass means that I can look through the perspex and see what the story is as far as fluidity within that tank. So the fluid in this tank is defined here by increments. And of course, do I have to read those increments? Not really. All you have to do is look in there and say, okay, yes, there is oil in there. Is it enough oil? Well, ultimately, if it's to the 3/4 of a tank of oil, it's more than sufficient to do the job. The one thing to remember too when you're running hydraulics is that if you, say for example, put the auger on and thought, right, I'll go and have some smoko. Well, the auger's doing a job. It's pushing the material aft of the machine. And of course, it's got to go somewhere into the drum. So remember that there's got to be a guy there to facilitate the material coming out of the machine. But also too, if I just turn those hydraulics on and wander off and go and have morning tea or afternoon tea and don't watch what's going on, ultimately hydraulics are high pressure, they're going through valving, so if you just leave it going for no reason whatsoever, ultimately it gets hot. So not only are you warming the valve planetary, but you're also making the oil hot. Does it happen? Some people have thought wiser and I'll just leave that on, it doesn't really matter. It does matter. If you don't need it, don't use it. So don't leave the hydraulics on for no reason. Once you've finished augering the bottom of the tank or evacuating the bottom of this vessel, turn it off, okay? Because the motor's turning something it doesn't need to. So utilise it when it's required, turn it off when it's not. So here we are around the final side of the unit. So we've basically done a walk around for you. You've got a red lever here, which engages the twin disc box, or the clutch as we call it. And this black knob here is your throttle control. Also here we have a caution label, another one to adhere to. To engage fan clutch, number 1, engine RPM at idle. So I would not put 1500 RPM over this engine and then try and engage this. Because what's going to happen is the clutch inside this is trying to override centrifugally and engage. So it's doing this. So if you have maximum revs on this, it's going to destroy itself. It'll just decimate the whole thing. So it's imperative that you adhere to that recommendation. And it's a caution, so therefore it's a must do. Engine RPM at idle. So on your control box around there is an RPM gauge. So that rev counter or tacho will tell you where your engine is. So if you're not sure, don't pull that up, go around and have a look. Number 2, engage clutch lever slowly. So what they're saying is you don't go, oh, she's in, see you later. Basically what they're saying is engage it slowly. Why would I engage it slowly? What's the difference? Well, just at idle, it's ticking over beautifully. So this here is going to drive this primary drive for your fan. So there's quite a lot of torque that's going to come on to this particular clutch when you engage it. So if I just go like this, it's going to go bang, oh, and fly to pieces. So the whole idea of this, and I would never do this with the engine running, what you do with a twin disc box is, remember this because this is the proper way to do it. You'll run it up until you feel there's resistance. So you can run it up and let it off, run it up and let it off. But what you're doing is you're bringing this up to speed. So ultimately what I'll do is I'll lift it up and feel the resistance, and you'll hear this start to engage. It'll start to spin. So as it's starting to spin, now you're bringing everything into a line. So the minute you hear everything come into line, bang, like that. So what I don't want you to do is go zoom, 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 pull it into gear. All you need to do is bring it up, feel the resistance, watch your pulleys, watch the pulleys, watch the pulleys. They're up to speed, up to engine speed, clock it in. Now, having said that, is when I bring the revs up now to 1600 revs. So this engine here is going to run at 1600 revs all day. But now it's up on 1600 revs. It's just as important on the 1600 revs on the engaged side that you don't at 1600 revs go, time to go home, because that's just gone, oof. So all that inertia, all that torque has got to have somewhere to go. You've just let it go in such a way that the whole thing's just gone, whoa. And it can actually collapse like that, exactly like that. So with that engaged and those revs on, before I remove this lever out of engagement, I'll back the revs off, and you'll hear the engine revs, the RPM dropping slowly, and you'll know that when you turn that so far, it doesn't turn anymore, and ultimately it doesn't adjust the revs anymore. Once the revs, leave it a few minutes. So what I do is I just walk around and just check things, make everything's in good stead, and then just come along and gently just go like that. That's it, push it out. So what I don't want you to do is when you release it, is go, oh, release it slowly and just hang on to it, like so. When you release this and pull it out, all you do is put your hand over the top, push, that's it, walk away. So now you've dropped the revs off, let it run for a few more minutes, let it settle down and switch it off. So let's just do that one more time so that you understand. Revs off, idling. Hold the lever up, feel it touch, feel the resistance, look at the engine speed in relation to pulley speed. When you think it's right, bang, into gear. Okay, so you don't be rough on it, gentle. So gentle does the job. Then increase your revs, 1600 revs. How many 1600 revs? We'll do 3 turns. Go and look at your tacho, your rev meter. If you're only up to 1200, come back and just turn it slowly, slowly. There's no need to go, I'll turn it right up and that'll fix it. Just slowly turn it up. Go back and check the RPMs again. Make sure it's right. Once you get to 1600, but don't panic if you go up there and it's 1800, that's fine, just come back. Turn it back slowly. Periodically check, make sure the two are in sync. It's all good. So now that we've got the thing running, at 1600 RPM, goes all day. It's all good. But at the end of the day, when I want to disengage this clutch, slowly remove the revs off the engine. You'll hear it come back to idle, and then you'll find that you can keep turning that and the idle speed doesn't change. So once there's no change in turning this counterclockwise, all I do is put my weight over the handle, disengage. That's it. So remember that. So what else have we got written here? When clutch is engaged, increase engine revs slowly. We've mentioned that. It's always slowly. Never just come along and wind the thing up because it's all got to catch up. The other thing is failure to follow this instruction will cause belt damage. Not only belt damage because the belts will slip when they're trying to keep up with the inertia that you've just increased on the pulley, but also too, this poor little twin disc box is going. So it's always slow, not too many revs, and gentle on this. And you'll have trouble-free operation of this particular piece of equipment. To be quite honest with you, this is all our call-outs here. It's because people don't read this, don't understand it, don't comprehend it, and don't coincide and abide with the rules and regulations in relation to this piece of equipment here. So this is a contentious issue in relation to operation. If you follow what I've just described, you won't have any problems. It's when you ignore that, have full revs on it and try and engage this sort of thing, or you're rough on it, you're really just asking for trouble. And ultimately, when we come to site to repair this, the minute we start pulling to pieces, the damage tells the story and we know what you've done. So whilst the machine's now null and void because someone's been rough on it, you don't have a dust collector until it's repaired. So if you follow that procedure, it'll all be good. This item here is a battery isolator. What it does is it isolates the power from the battery to the engine. So don't forget, if you go around to the other side of the unit, go to start it, nothing happens. Hello BlastOne, the unit doesn't work. Don't forget that you need to check the battery isolator. So if it is operated, breaks the power to the other side, simple check like that can be the difference between going and not going. It's labelled, easy to identify, you know what it is. So while we're at this end of the unit, there's also another shaft here, which is your main drive shaft for your fan. On the top of this are 2 more grease points. These ones do have caps on them. Sometimes you get them with caps, sometimes the caps get lost or they go missing or people break them off. So remove the cap, a couple of pumps of grease each day. Make sure that it is lubricated appropriately. On the other side of this ducting is your auger shaft. So I showed you the grease nipple on the shaft on its aft end. On this forward end, there is another grease nipple that you need to do. So there's 1, 2, 3, 4 grease nipples. But on the twin disc box, there's 2 more. So those 2 additional grease nipples have to be done, a couple of pumps daily. So we've got 1, 2, 3, 4, 5, 6 nipples. So if you put them in your daily maintenance chart and say, okay, then there's 5, or how many nipples? There's 6. So at least when somebody's greasing this, they come back and say, yeah, I did those 4 nipples. Hang on, mate, there's more than that. So if you write the amount of nipples in there, at least that way you know they've been addressed daily, you know the lubrication's there, and you know that you won't have any premature failure because I've failed to maintain or lubricate these particular items. They are a critical item and they do need to be lubricated.